All right, everyone, so let's go back to what we were doing. So we have the following corollary. Let n be bigger than 1, be an integer, and consider congruence modulo n and then if a is any integer and r is the remainder, when a is divided by n, then the class of A is equal to the class of R. And the second thing, there are exactly n distinct congruence classes. Namely, zero, 1, up to n minus 1. All right, so proof. So first one, let A belongs to Z. Then we can do the division algorithm. Then we can, or let's write by the division algorithm, or using the division algorithm, or by invoking the division algorithm, we get A is equal to n times q plus r, where you have that r is less than n. Then it follows that A minus r is equal to n times q. Hence, A is congruent to r mod n. And so, by the previous theorem, we have that the class of A is equal to the class of R. All right, so now let's look at part 2. So, if A is any congruence class, of the congruence class, then it follows by 1 that have the following. The class of A belongs to the following classes from 0 to n minus 1. So all we have to show is no two classes are identical. So suppose S and T are integers that are distinct, where you have that S and T are between 0 and n minus 1. It follows that one of them is bigger than the other one, so suppose that S, it follows that without the loss of generality, that S is less than T and less than or equal to n minus 1 and bigger than 0. Hence, it follows that you have that they are distinct. Their minus is also distinct. So T minus S is less than N. So hence N doesn't divide T minus S. So they are distinct. So the classes are distinct. Hence, or let's just say, therefore, the class T is not equal to the class of S mod N. Or let's just say, yeah, not equal. Not equal. And every two elements of the classes from 0 to n minus 1 are distinct. So therefore, let's call this C. Therefore, C has distinct elements. And we are done. So let's record the following definition. The set of all congruent classes modulo n is denoted as Zn. Yeah. Which is red Z mod n. And we're done. So yeah, I'll finish this video over here. So I hope you guys enjoyed this video, and I'll see you guys in a later one. Bye.